Likewise, in R, you have a simplest data type that is known as vector. So we'll now go into vectors first, right? So let me now take you through a second script here, which is your R vectors, right? So vectors in R, vector, right? So, and now we are on a script that is vector.r, right? So the first important thing, vector is the simplest data type in R, right? It is a unidimensional data type. It contains some several values which are combined together into a single variable, right? So for example, here you are creating a data object, a vector with combine. So the C is for combine or concatenate. And what I'm saying is, let's say for somebody, I'm giving the marks in 6 or 7 subjects. So I say marks is equal to combine 85, 88, 90, 76, 88, 80, and 87, right? So this is the marks obtained by one student, right? And what I want to do here is, with this marks, I want to calculate the mean and also the median for this marks. So marks equals to combine, and then whatever values you want to get are given within round brackets, so it's separated by commas. So this is the typical, the syntax for creating a vector. So marks equals to this here, right? And then of course I want to see whether my marks has been created. So I say print and in bracket the variable marks, right? So I run and I give it here. And if you see immediately on the panel here, the variable panel here, the environment, you have the marks variable and the values are from number 1 to 7, and the values include 85, 88, 90, 76, 88, 80, and 87, right? So this is to indicate that this variable is now in the environment here, right? And then, of course, it shows me here print marks, and I could also say directly just marks, and it will show the values that are contained in the marks, right? So this is 85, 88, 90, 76, 88, 80, 87, right? Now, the first thing I want to know is whether I have input the marks for all the subjects or not. So I will check. Let's say I have 7 subjects. I will say whether my vector contains 7 values or not, right? So I'm saying length marks. So the command for that is, I'm checking for the number of elements in my vector, and the command for that is length marks. And I say run, and I get the value of 7. So there are 7 values in my vector. And let's say I had 7 subjects. So now I know that I have values for all the subjects that I had included here, right? So length marks gives me the number of elements in my vector, right? Now, if I want to access my individual elements in a vector, right? So I want to see what is the first marks that I've entered here. So I can directly say marks, which is the name of the variable, which is the name of the vector here. And in rectangular brackets, I can give the value of the position I want to look at. Now, one thing that is important here is if you had done this in Python, you would know that this is in Python, the arrays or the list is 0 indexed. But here in case of R, it is 1 index. So the first item goes at the 1th position, the first position. The second item goes to the second position. In many cases, what happens is both in Perl and in Python, the arrays or the lists are 0 index. So the first item goes at the 0 index. Here in this case, it goes to the first position. So when I say marks 1 and I say run, you'll get the value of 85. If you were to declare a list in Python, then it would go at marks 0 position, right? So this is something that you need to keep in mind, that in R, the vector is 1 indexed. So the first item goes at the first position, not at the 0th position. This is the number of elements in a vector. So you do length marks and you get your number of elements here. Then you are accessing individual elements in the marks vector. So you give the position, and here the position starts from 1. So when you say marks 1, you get the value of 85. Then you want to see what is the summary of the values in your marks vector. So what you can do is you can use the command summary directly and say summary, and in the argument. So what you're doing is this is the command, summary is the command, and which vector summary you want to see, you are giving it in the brackets here, round brackets. So this is the argument you're giving, right? And then when you run it, it gives you the summary. So it gives you minimum value, it gives you the first quartile, the median, the mean, the third quartile, and the maximum value, right? So this is a direct statistical analysis of the data that is given in. So it gives you almost all the values that you want up here, right? Then you want to check what is the class of the data that you've given. So this is a vector. A vector could have a character class or a numeric class. So if you want to check that, the command is class, right? And this becomes important. Sometimes I'll show you an example where this becomes important. So here is your class marks and you run it. And this gives you that the class of the data that is included in the marks vector is numeric because all are numerical values here, if you see, right? So when you define all values are numerical, right? Now, if you want to calculate the total marks obtained by the student, so you can use the sum command, right? And now what I'm doing is I'm transferring the value of some marks into a variable called total marks. And then I'm trying to also print it in a nice way. So I use what is known as the print command. And in print command, because I am using an alphanumeric character total marks, and then I'm using a numeric character, which is your total underscore marks, which is the value of the sum here. So you use an additional what is known as the paste command here, right? So this is how you would basically uh, print out a result with the additional remarks that you want to give here. So I'm saying total marks is equal to, and then total underscore marks is where I'm calculating the sum here, right? So if you see, you run it, and you get your total marks equals to 594. So whatever you give here in this double inverted commas will come as such, and then the value of the variable that into which you have calculated the total marks will come here. The command is sum, right? So this is a function, right? So remember, so instead of saying x equals to 84 plus 85 plus 87 plus this plus this plus this plus this, and you could have 100 numbers here. So remember, what I'm showing you is on a small data, but actually the utility comes in when the data is huge, right? So, and always remember when you make a program, first you run it on a small data so that you know exactly what is the expected output, so that you can match whether the expected output has come or not. And as your basic program gets ready, then you apply it into the larger data. In the larger data, the thing is that there may be some exceptions. So you may have to then deal with those exceptions in a separate manner. But whenever you're writing a program, first run it on a small set of data which you can manually calculate and corroborate that what the program has found is correct or not, right? So coming back here, class, this is your sum. This is your, again, a function in R, which can directly total out the entire number of numerical values present in a vector, right? So this is your, and again, you select the part and you run, right? And once you run, in the console, you'll get the output here. And tomorrow I'll tell you how to write the output into a file also, because you cannot keep getting your output in the console and not write to a file, because ultimately when you submit your reports and everything, you need the data written onto a file that is submit. So tomorrow we'll talk of file handling in R, and I'll tell you how you can write back your data onto a file. Right now we are doing it all on console because we're trying to keep it simple and sweet, right? Then you can calculate the mean. So I use average marks as my variable, and then I say mean. And mean is again a function which is inbuilt into R, so you don't have to do anything. And you just have to feed in which vector you want the mean for. So when I say average marks equals to mean marks, it can directly give me the mean or the average for the data here. So I say run, and it says average marks obtained equals 25. And this is because I'm using the paste argument. So when I use paste, it is able to take both alphanumeric and numeric values and put them together. And what I'm also doing is I'm using a round command to round off the average marks. So it could be in decimals. If I don't use round, let me see what happens. So you could do a bit of modification here. So if you see now, I've removed the round command, and then of course, if I run it again, so you see, you have a whole lot of decimal places that are given to you, and that may not look very nice. You can also control how many decimal places do you want the average marks to be printed, right? So I could also give a command that gives it only to 2 decimal places, which would be a nicer way of presenting it, because 84.85 is not the same as 85 as you see here. When you round it off, it becomes 85, but actually it is not exactly the same, right? So therefore 2 or 3 decimal places is what we would prefer, so that can be done again. So this is your homework now. How do you print a particular numerical value until a certain decimal place, right? What's the syntax for that? as your homework. So then we move on and we talk more about other measures of central tendency. So let's say you want to calculate the median. So you could directly say median marks equals to median again as a is a command. So remember also when you use these variable names, you cannot use a variable name that is already a command in R. You cannot say median equals to median marks, right? And also when you use variable names, it is important that you use a descriptive variable name. Descriptive variable name means that when you see median underscore marks, you understand, of course, that what you're looking for is a median. I could also say A equals to median marks, right? So I could also say A equals to median marks, but that would not indicate. And what happens in a short program, you would still be able to see the command and correlate that A stands for median marks. But when you write 10,000 lines of code, it gets really difficult to understand what each variable is doing. And A, B, C are only, 26. So how do you go beyond that? So therefore, it is always good to have a descriptive variable name, which is very indicative of what value it carries. So this is the median marks. Median marks equals to median and marks, and then you say run, and you are here, right? And let's say it is 87, right? And then, of course, if you move on further, and let's say you want to double the values in your vectors, so you can directly say double underscore marks equals to 2 asterisk marks, right? So remember, your marks is your initial vector. So let me print the marks vector first, and then so that you have a comparison. So marks, right? So this is your marks first. Run it. And now you're trying to double every single value in the marks. So directly you can do double marks equals to, and this is of course a variable name, it could be A, X, Y, Z equals to 2 asterisk marks. And then you print the value of double underscore marks here. So you say run, and you get double the values: 85, 170, 88, 176, 90, 180, 76, 152, 88, 176, 80, 160, and 87, 174, right? So you know now this is how it works out. You could also halve the marks, so you can directly say half the marks, and this will work again. You say run, and this will now you get the half the value. So 85 is 42.5, and so on and so forth. I'm sure you're following this. Then you could have two different vectors and you want to multiply them, and you could have actually vectors that have similar number of elements. So let's say you have a vector A, and this is basically, again, now you remember how do you specify a vector. You use a variable name, you equate it to something, and then you say concatenate or combine, and then give your numerical values in round brackets, right? So vector is the simplest data type in R. Remember that, right? Vector is the simplest data type in R. Ultimately, when we talk of data types, we mostly will be dealing with data frames, and we'll come to that in a moment. So here you are, you're multiplying your vector by 2. So you have A equals to C, 1, 2, 3, B equals to concatenate again or combine again, 4, 5, and 6. So these are two values. So what happens when you multiply two vectors together? So when you say AB equals to A asterisk B, right? So AB is the variable again. And what is coming up here is the multiplication product of these two vectors. So what would happen is each position will multiply by the other position. So you'll have 1 into 4, 2 into 5, and 3 into 6. So let's see what we get in AB here, right? So you say run, and again, if you see, this is what you get. So 1 into 4 is 4, 2 into 5 is 10, and 6 into 3 is 18, right? So this is what you get here. You could also do a division here. So AB div is the variable I read. So I'm deliberately using a variable that gives me an idea of what I'm doing here. That is what is known as a descriptive variable name. And when you write your programs, you must always use a descriptive variable name. So here is what I do: AB div, A by B, AB div, and I say run, and now you get the values. 1 by 4 is, so if you see here, 1 by 4 is 0.25, right? And then 2 by 5 is, of course, what is 2 by 5 class? 0.40, and 3 by 6 is 0.5. So now, again, if you want to come back to the individual elements in the vector, so again, you can write AB1, and it gives you the first element. And remember, again, there is no zero indexing in R. It is one indexing, the first element. So 4 comes up here, right? Likewise, if you write AB4, there is no fourth element here. If you see, there are only 3 elements in AB, 4, 10, and 18. So when you write AB4, you'll get a error message or NA message. So this is not applicable. There is no value in the fourth position in AB. So it gives you an NA, right? Then there are certain things that you can do in a vector. You could combine a vector to create a new vector. So you say Z equals to combine A, B, and A together, right? So if you remember, A and B vectors are, so let me just give you the values of A and B here so that you know what is your A vector. So I say A, I could also say print A, and I say B, right? So this is what we are doing. So we say A and B, and you get the values of A and B. So A is 1, 2, 3, B is 4, 5, 6. Now what I'm doing is I'm creating a new vector where I'm combining the values of A and B in a certain order. So I'm creating Z or Z, which is equivalent to concatenating or combining A, B, and A. So when you do that, this is the new vector you create, right? So let's say I say print Z. So when you print Z, this is what you get. 1, 2, 3, because the first vector was A, then the second vector was 4, 5, 6. So you have these values again, 4, 5, 6, and then the A vector again, so 1, 2, 3. So you could calculate the how many elements are there in this vector. The command is length, 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 and you say Z, right? So this will give you the number of elements in a vector. So you say length Z, and when you say run, it gives you 9 now, right? You see, so this is 1, 2, 3, 4, 5, 6, 1, 2, 3. There are 9 elements in the Z vector now. So now what you can also have is a character vector. Until now we have had a numeric vector. You could also have a character vector, right? So for example, here I give a vector. So the vector variable name is my underscore name, and I say combine, and I say the first element is my, the second element is name is weapon, right? So this is what it is, right? And then of course I can print my name, and this will give me run here, right? And then I want to see what type of vector this is. Remember, when we talked of marks, we talked of again the class command, and I said class marks, and it gave me numeric. Now I'm looking at what is the class of my name vector, my underscore name vector. So when you say run here, it gives me character, because this is no more numeric, right? It is mostly characters here, right? There is no numerical value. All right. And then if you say summary my name, so it gives me again a bit of summary here. Of course, you will not have any numerical value here, so it doesn't give you a mean or first quartile or second quartile. It just gives you the length, which is 4, 1, 2, 3, 4 elements here. Then it is class is character, and the mode is also character, right? And then I could have a vector that has combined values. So for example, here I am saying numbers vector equals to concatenate or combine 1, and then so 1 is a number here, 2 is a character, 3 is a number again, 4 is a character again. So what is happening here is this is what you define as a vector here. You say run, you get this one. Then you look out the values for numbers. So you simply write numbers or print numbers. And when you do that, it gives you run again. It gives you 1, 2, 3, 4, right? And remember, these are inverted commas here, right? So basically, this indicates that even your numbers that you've given are now being treated as characters. So you say class numbers. So you want to check what is being treated as the individual elements. What is their class? So you say class and numbers, and you say run, and it gives you characters, right? So now even your numbers that you put in a vector along with characters. So numbers also are now being treated as characters now, right? So you cannot perform any arithmetic operation on these individual values also. You follow class? Then in a combined vector where you have both characters and numbers, even the numbers that you give are treated as characters, and you cannot perform any mathematical operation on those numbers also, because one that you see here is not a number for this software now, for R. It is a character. You follow class, everyone? So then if you see here, so num1 equals to numbers1. So you are now, what I'm trying to do now is to pick up the first character in my numbers vector and equating it to num1, right? So num1 equals to number 1, right? So numbers 1, so this will take the value of 1, right? right? And what I want to emphasize here is how this works out. Then I print my num1. So it says run and it gives you num1. Remember again, num1 is now carrying the value of 1, but 1 here is not a number. It is a character because it's coming from a vector that has characters as well as numbers. So it is, if you see, class numbers is a character. So when you pull out an individual value from this vector, this is while this will show as 1, it will be treated as not as a number but as a character, right? So when I look at class num1, right? So what is num1? This is the first item in the numbers that are equated to num1. So I say class num1 and you would say run. This is still a character. Let me show you a value of 1 here. It is still a character. It is not a numerical. It is not being treated as a numerical. If I say num1 plus 2, this will give me an error message because num1 is not a number. It is a character with a value of 1. So when you say run this, it shows error in num1 plus 2 non-numeric argument to binary operators, right? So binary, what is this? This is a operator plus, and it has been given a non-numeric argument because this is num1 which has a value of 1, but 1 is not numeric here, it is character. So therefore num1 plus 2 gives you an error. If you still want to do this, then what you can do is you can use this command as dot integer num1. So now, while it was initially a character, it will be used as an integer, and then it is adding to a to 2, and it will give you the value here. So if you use this here, I think you can do this, right? So guys, I think, I mean, we can go on with this for some more time if you want, or else if you want, we can stop here. We have done the basic data type in R. Tomorrow we go on to matrix and data frames.